For pretty much all of human history, the genetic lottery was it. The code you were born with, that was your code for life. But that's just not true anymore. Humanity, we now have the power to literally edit the building blocks of life itself. So yeah, let's dive into this. It's an incredible and incredibly complex new world.
And really, it all kicks off with this one incredibly powerful question. A question that's just full of hope. I mean, what if we could just eliminate genetic diseases forever? Just completely wipe things like cystic fibrosis or Huntington's right out of our family trees for good. That one idea, that's the engine driving all of this science. But as you can imagine, it also opens up a huge debate about where we're all headed.
Okay, so before we get into the deep ethical weeds, we've got to understand the tools first. I mean, how did we even get here? Because let me tell you, the scientific leap that made this possible is nothing short of staggering.
This whole revolution really stands on two pillars, two powerful technologies. On one hand, you've got assisted reproductive technology, or ART. You've probably heard of its most famous example, IVF, which has been helping people build families for a while now. And on the other hand, you have genome editing, the actual ability to go into our DNA, the code of life, and make very specific changes. Now, when you put those two things together, that's when you unlock something brand new, something that changes the game entirely.
Look, gene editing wasn't impossible before, but it was incredibly hard and clunky. Then this thing called CRISPR-Cas9 comes onto the scene, and it just completely changes everything. And I'm not exaggerating here. This is genuinely one of the biggest, most important biological discoveries of this century, period.
So what's the big deal with CRISPR? Why was it such a breakthrough? Well, think of it like this. The older tools were kind of like trying to do delicate surgery with, a giant wrench. They were complicated, super expensive, and not very accurate. CRISPR comes along, and it's like a pair of high-tech molecular scissors. It's cheap, it's fast, it's incredibly precise, and it's relatively easy to use. It basically took gene editing from being this super specialized niche thing and put it in the hands of almost any scientist anywhere.
And how it works is actually pretty elegant. You can break it down into 3 basic steps. First, you program CRISPR to find one specific little spot in the entire massive library of our DNA. It's kind of like a biological Google search. Second, once it finds that exact spot, an enzyme that travels with it, Cas9, acts like a tiny pair of scissors and just snip, it cuts the DNA. And third, the cell's own repair crew rushes in to fix the break. And that's when scientists can sort of nudge it to paste in the correct code. So you find, you cut, and you repair. Simple, right? But so powerful.
Okay, so we have the tool, but how does this jump from a lab into our actual lives? Because we're not just talking about changing some cells in a dish here. No way. We are talking about making changes that could literally rewrite the family tree for individuals, for their kids, and for every generation that comes after.
And the promise here, the upside, is just immense. This is what gets scientists so excited. We're looking at the potential to treat some truly devastating conditions. I mean, actually correcting the gene for Duchenne muscular dystrophy, or maybe even cutting the HIV virus right out of a person's DNA, fixing the faulty gene that causes cystic fibrosis. This could even offer new hope for diseases like Parkinson's. This isn't just a small step forward. This is a potential revolution in how we do medicine.
But, and you knew there was a but coming, with all that incredible promise comes a whole cascade of really tough questions. Because the exact same power that could cure a terrible disease, well, it could also be used in ways that make us all feel pretty uneasy. And this is where the pure science kind of stops and the huge societal debate really begins. And it really boils down to this one massive question. Where do we draw the line between therapy and enhancement, right? I mean, curing a disease, that feels like a no-brainer. But what about using this to make someone taller, or smarter, or a better athlete? Is stopping someone from going bald therapy? What about changing their eye color? You can see how that line between fixing something and improving something gets real blurry real fast.
So to even begin to think about this stuff, we can use a framework called bioethics. It's basically built on 4 big ideas. First, you have autonomy. That's respecting a person's right to make their own choices. Then there's beneficence, which just means trying to do good. And its flip side, non-maleficence, which you've probably heard as first do no harm. And finally, there's justice, which forces us to ask about fairness for everyone. Pretty much every single argument about gene editing is just people trying to balance these 4 principles.
And when you start talking about using this technology on humans, a bunch of really serious red flags pop up immediately. You've got the historical nightmare of eugenics, the whole idea of designing better people. Then there's the issue of consent. I mean, how can an embryo consent to having its genes changed? How can generations that don't even exist yet consent? And then, of course, there's the big, scary question of safety. What if we make a mistake? What are the unintended consequences down the road?
And listen, these aren't just abstract sci-fi worries. They lead to some very real and, frankly, unsettling possibilities that are on the table right now. We're talking about designer babies, where parents could pick and choose traits like eye color or maybe even IQ. Or the idea of save your siblings, creating a child specifically to be a perfect tissue match for a sick brother or sister. And then there's the biggest one of all, germline editing. That's where you make a change that isn't just for one person, it's passed down to their children and their children's children forever. It becomes a permanent part of what it means to be human.
And just to give you a sense of the scale of these ethical problems, look at this one number, 400,000. That's roughly how many frozen embryos are in storage right now, just in the US alone. This is a side effect of IVF, and it creates this huge debate about what are they? Who decides what happens to them? It's a massive ethical puzzle we already have, and that's before we even talk about going in and editing them.
So, okay, the science is moving at lightning speed. The ethical questions are piling up. So what's the world doing about it? Are there any guardrails? Are we building any rules for this new road we're on?
The short answer, not really. There is absolutely no global agreement. When you look at editing human embryos, you've got about 24 countries that have flat out banned it by law. Another 9 have banned it with professional guidelines. But a whole lot of other places, they have no strict rules at all. What you end up with is this completely fragmented, chaotic patchwork of laws and ethics. Everybody's going in a different direction.
And check out this quote from a doctor in Ghana. It really just brings the whole thing back down to earth. This isn't some ivory tower debate for philosophers. The people actually doing this work on the front lines are asking for clear rules. They need a system to guide them, to protect everyone involved. They're basically saying, hey, we need some laws here and we needed them yesterday.
Now, a huge reason why we can't agree on this stuff is that we're all starting from different places with different core beliefs. For example, the Catholic Church generally believes that life begins right at fertilization, which makes many of these procedures problematic from the get-go. Meanwhile, many Islamic scholars value reproduction but emphasize it must happen within a marriage. When you have these deep, powerful, and sometimes conflicting worldviews, trying to come up with one set of rules for the entire planet, well, it's almost impossible.
So all of this, it brings us to this really pivotal moment. I mean, we are literally standing at a genetic crossroads, and we have to make choices that are going to shape the future of our species. No pressure, right?
And this is the core conflict right here. On one side, you have this incredible, undeniable power to heal suffering, to end diseases in ways we could only dream of before. But on the other side, you have these huge ethical risks. The danger of turning life into a product, of making society even more unequal, and maybe even changing what it means to be human, forever.
So where does that leave us? Well, there are no easy answers. It's really something for all of us to think about. Is this power to edit our own code a fundamental right? Is it a risk that's just too great to take, or is it a profound responsibility, one that we have to learn to handle with incredible wisdom and care? The conversation is just getting started, and honestly, how we choose to answer these questions is going to define all of our futures.
Imagine we've opened a new frontier. I mean, a place where we can fundamentally reshape life itself. But with that incredible power comes, well, a storm of ethical dilemmas, legal battles, and deeply personal choices. Today, we're diving deep into bioethics, reproductive technologies, and genetic privacy. And this isn't just for specialists, right? It's about decisions that touch every one of us, defining what it means to be human and shaping our shared future.
Exactly. We've pulled together a pretty rich collection of sources here, everything from, say, Harvard Law School's insights into reproductive law to cutting-edge research on gene editing, and even how global privacy laws are, frankly, scrambling to keep up. Our mission for you, our listener, is really to extract the crucial nuggets, connect the dots, and help you navigate this complex landscape.
Yeah, think of it as a shortcut to understanding the aha moments and the really interesting facts about how we're shaping life itself, what rights we have, and who gets to decide. So as we map this new frontier, what stands out to you as the most significant shift right now, especially in how we approach parenthood?
I think the biggest shift is just the sheer expansion of possibilities. Thanks to these incredible advancements, the traditional paths to parenthood, well, they're no longer the only ones. We're seeing career-oriented women, gay and lesbian couples, single individuals, infertile couples. They're all benefiting. It's fundamentally redefining what a family can look like.
And the technologies themselves are just remarkable. We've all heard of IVF, right, where fertilization happens in the lab. But our sources highlight some fascinating, maybe more nuanced methods too, don't they?
Absolutely. Beyond standard IVF, you've got gamete intrafallopian transfer, or GIFT,
Yeah.
that places both ova and sperm directly into the fallopian tubes.
Okay.
So fertilization actually happens inside the body, kind of mimicking a more natural process.
Right.
And then for male factor infertility, there's intracytoplasmic sperm injection, or ICSI. That allows a single sperm to be injected directly into an egg,
Wow.
which dramatically boosts success rates for many people. These aren't just, medical procedures. They're powerful tools challenging traditional definitions of family and identity.
Okay, here's where it gets really interesting for me. We're even seeing what some are calling three-parent babies with mitochondrial transfer. Could you tell us a bit about how that works? It honestly sounds like something straight out of science fiction.
It kind of does, yeah. Mitochondrial transfer involves taking cytoplasm, which includes the mitochondria from a younger donor egg, and injecting it into an older egg, or maybe one with compromised mitochondrial DNA.
Why do that?
Primarily to prevent the transmission of certain serious mitochondrial diseases from mother to child. That's the main goal. So the egg, now containing nuclear DNA from the intended mother and mitochondrial DNA from the donor, is then fertilized with sperm.
So the resulting child really does have genetic material from three individuals.
That's right. And while it's a very new technique, the early data does show some promise in increasing developmental success.
With such power, though, to shape life, the ethical questions just become profound, don't they? Our sources get into some pretty fundamental philosophical viewpoints, like the natural law perspective.
Right.
What does that specific, quite strict view tell us about these technologies?
Well, from the natural law perspective, which often stems from the Roman Catholic Church, any technology that separates the sex act from conception is seen as intrinsically immoral.
Intrinsically immoral, I guess.
Yeah. It emphasizes respecting what's perceived as the natural order, where reproduction occurs naturally through sexual intercourse. So procedures like artificial insemination are problematic, not just for separating the act from conception, but also because they might involve acts like masturbation, which is considered prima facie wrong in this framework. It's a very, let's say, uncompromising interpretation.
That's certainly a strict view. And for many people, it probably stands in direct opposition to their personal desires for a family. So how does modern bioethics, with its, wider lens, try to navigate these fundamentally different moral compasses, especially around reproductive technology decisions?
Modern bioethics often leans on a framework called principlism. It was developed by Beauchamp and Childress, and it's basically designed to guide us through these difficult decisions using 4 core principles.
Okay, what are they?
First is autonomy, the right and capacity for individuals to make their own choices. Then beneficence, which means promoting good outcomes. Non-maleficence, the duty to avoid harm, the famous do no harm.
Right.
And finally, justice, which addresses the fair distribution of benefits and costs. These principles give us a sort of structured way to evaluate the ethical implications, especially when we're considering choices like offspring selection.
Designer babies. That phrase alone, it sounds almost utopian to some, but terrifying to others. What are the core dangers our sources warn us about when we start down that path? And how does that connect to something as, emotionally charged as a savior sibling?
Yeah, the concern here isn't just about playing God, as some might say. It's often more subtle than that. It's about whether creating children with pre-selected traits, whether it's eye color or avoiding a disease predisposition, fundamentally shifts our relationship with them.
How so?
Well, do they become products we've designed rather than unique human beings we cherish unconditionally? That's the fear. This also applies to selective abortion, where embryos might be aborted for non-fatal disorders. It raises questions about, trying again for a better embryo. And the savior-sibling concept, like you mentioned, where a child is conceived specifically to provide tissue for an existing sick sibling, like in the movie My Sister's Keeper.
Right, I remember that.
It sparks debate about using a child as a means to an end, rather than valuing them purely for their own sake.
And what about the sheer volume of unused embryos from IVF? Our sources mention as many as 400,000 frozen embryos in storage in the U.S. alone. That's a staggering number. What are the ethical dilemmas there? And the proposed solutions for these excess embryos, it feels like a kind of silent ethical time bomb.
It truly is a significant and frankly ongoing issue with no easy answers, precisely because there's no single consensus on the moral status of an embryo. That's the core problem.
Right.
So the options include indefinite cryopreservation, donating them for reproductive use by other couples, disposal, or donating them for scientific research or training. But the ethical quandaries just multiply exponentially in cases of divorce or the death of the parents.
Oh, wow.
Yeah, it raises incredibly complex questions about legal rights, responsibilities, and what constitutes the best interest for these potential lives.
The dilemmas of excess embryos really highlight how profoundly we're already intervening in life's earliest stages. But what happens when we go beyond creating life to actively rewriting its very blueprint? That brings us to human gene editing, a technology that truly feels like science fiction becoming reality. What are the key breakthroughs there and the ethical considerations that immediately jump out?
Human gene editing, especially with technologies like CRISPR, allows for just unprecedented precision in modifying a genome. You can do insertion, deletion, or replacement of genetic material. The critical distinction that drives a lot of the debate is between therapeutic purposes.
Like fixing a disease.
Exactly.
Right.
Like correcting a single gene mutation to treat a monogenic condition versus enhancement purposes.
But making someone smarter.
Potentially, yeah.
Yeah.
Augmenting traits like intelligence or maybe making us immune to certain diseases. Our sources definitely warn about potential unforeseen genetic consequences down the line. Also, the risks of non-consenting human subjects research, and especially with germline editing.
That's the one that changes future generations, right?
That's the one. It makes permanent, heritable changes. The ethical implications there are enormous.
Given all this complexity, the whole concept of informed consent becomes absolutely critical. It's foundational in medicine. But genomic sequencing must throw a massive wrench into that reasonable patient idea, right? Our genetic code is just so incredibly complex. What makes informed consent so uniquely challenging here?
You've really hit on a key point there. Informed consent at its core is about autonomous authorization, right? Letting the patient decide. Historically, the courts shifted from a sort of physician-centric standard, what doctors usually disclose, to a patient-centric one, what a reasonable patient would need to know to make an informed choice. But genomic sequencing fundamentally breaks that model in many ways. Think about it. There are over 4,000 conditions linked to specific genes. It's literally impossible to explain all possible results.
yeah.
Risks and benefits can be unknown, or they might even change over time as our scientific understanding evolves. This just leads to information overload. It makes true comprehension incredibly difficult for the average person.
I can definitely see how that would be overwhelming. But beyond the individual, our genetic information also implicates our families, doesn't it? That must add a whole other layer of unique risk.
Absolutely. The familial nature of genetic info introduces really profound risks. Psychological stress, potential stigma, maybe even discrimination, not just for the individual, but for their relatives, too. We've seen some tragic cases, like with the Havasupai tribe, where DNA samples collected for one purpose, for diabetes research, were later used for entirely different research, studying things like schizophrenia and migration patterns, completely without the community's consent.
That's terrible.
It really highlights the profound need for community engagement and very careful ethical oversight of genetic data.
And what about those secondary findings? You know, the incidental information that's unrelated to the primary reason for testing. That sounds like another layer of complexity nobody initially signed up for.
It absolutely is. Patients often struggle to distinguish the primary findings from the secondary ones, which confounds their understanding of the risks and benefits involved. And it can cause family discord, too. Imagine a secondary finding in a child inadvertently reveals a genetic status in a parent.
Oh, right.
That raises questions about who has the right to know and who actually consents to that disclosure. It gets messy. And while GINA, the Genetic Information Non-Discrimination Act in the U.S., protects against health insurance discrimination based on genetics,
It is good.
it is good, but it completely misses areas like life insurance, long-term care, or disability insurance. That leaves individuals potentially vulnerable to significant future risks, risks which are hard to explain and can easily get amplified in a patient's mind.
So, okay, given all these challenges, what are the proposed solutions? Are there new models of consent emerging to adapt to this genomics era? Because the old ways clearly aren't quite cutting it.
Yeah, there are several innovative approaches being explored, definitely. One is staged consent. This allows patients to get general information up front and then specific findings as they arise. It helps alleviate that information overload.
That makes sense.
Technology-based solutions too, like interactive videos and decision aids. They're proving pretty promising for customizing information and improving comprehension. For secondary findings in research settings, there's a governance model being discussed. This allows a group of stakeholders, researchers, ethicists, patient advocates to decide together what kinds of unexpected results should be returned. It reduces the burden on individual consent for every possibility. Another option is outsourcing, where participants get their raw data and can choose to pursue findings with a third party, maybe a genetic counselor. And binning is another idea. It organizes secondary findings into categories, so patients could choose to receive, for example, only actionable findings, things they can actually do something about, like the ACMG's list of 59 genes.
Got it.
Ultimately, there's a clear recognition we need a more individualized and flexible approach, and genetic counselors play a absolutely crucial role in tailoring these complex discussions.
Okay, this brings us to the really crucial question of regulation then. Who gets to guard this incredibly personal and powerful genetic information? We're seeing, as you mentioned, a flurry of legislative activity, particularly in U.S. states. That seems to indicate a growing urgency to protect genetic data.
Indeed. There's an intense focus right now on genetic privacy. Montana's new SB 163, for example, which takes effect in October 2025, actually extends privacy obligations to neurotechnology data.
Neurotechnology data. What's that?
Information captured by technologies measuring nervous system activity, like brain scans, potentially. Montana's the third state to do that. It's a significant expansion of privacy scope.
Wow.
And then you have Texas's Genomic Act of 2025 taking effect September 1st, 2025. It specifically targets foreign adversaries, countries like China and Russia.
Really? How?
It restricts their access to genome sequencing data of Texas residents and even the use of their sequencing equipment or software. It's a clear national security focus.
Yeah.
Florida has a similar, though maybe narrower, law.
And at the federal level in the U.S., it seems there's also a push to protect genetic data, even in maybe unusual circumstances you might not immediately think of.
That's right. There's the Don't Sell My DNA Act, introduced just in May 2025. It aims to amend the federal bankruptcy code, requiring explicit consumer consent before genetic information can be used or sold during bankruptcy proceedings.
Bankruptcy.
It's a very specific but potentially important protection. And another bill, the Genomic Data Protection Act, focuses squarely on the privacy practices of those direct-to-consumer genetic testing companies, which have been, a growing area of public concern.
Moving beyond national borders then, how are different countries grappling with regulating assisted reproductive technologies or art? Our sources give this fascinating comparison between Spain and Israel, but both countries seem to have very pro-IVF legislation, but they take really different approaches, right?
Yeah, they do. Spain and Israel are both intensive users of RT. It's driven by factors like increasing age of parenthood and also distinct societal values in each place. In Spain, for example, gamete donation sperm and eggs is anonymous, and it involves significant compensation.
Yeah.
This creates a really active market, actually making Spain a destination for what's called reproductive tourism.
Right.
Surrogacy, however, is illegal in Spain, though many Spaniards still pursue it abroad. Israel, by contrast, has much more restrictive ovum donation laws. They actually disallow cross-religion donations,
Wow.
which leads to a scarcity of local egg donations, often supplemented by donations from abroad. Surrogacy is legal in Israel, but it's highly restricted, particularly for gay male couples, who often end up seeking cross-border options as well.
So despite their differences in approach, what are the shared concerns, or maybe the weaknesses that experts in both Spain and Israel are worried about? This is often where the really interesting insights emerge, I find.
A major shared weakness, yeah, and one that deeply concerns experts in both countries is the inadequacy of their donor registries.
Donor registries, meaning tracking who donated sperm or eggs.
Exactly. There are significant gaps between what the law requires and what's actually implemented on the ground. Without comprehensive centralized registries, donor-conceived children may lack access to vital genetic and medical history.
That sounds risky.
It poses serious risks, like inadvertent consanguineous relationships, relatives having children together without knowing they're related, and it limits the benefits of future family-based genetic sequencing for health purposes. Furthermore, experts in both countries express real dissatisfaction with the excessive impact of private commercial interests on the regulations.
Like clinics pushing unnecessary treatments.
Precisely, leading to practices like maybe an excessive number of IVF cycles or the promotion of unnecessary add-ons like PGS, pre-implantation genetic screening, which often offers only modest, if any, real clinical benefit.
Okay, this deep dive would definitely be incomplete if we didn't connect these technologies and regulations back to the broader human rights framework. What exactly are reproductive rights? It's a term we hear a lot, but its scope can feel quite broad.
Well, the World Health Organization, the WHO, defines reproductive rights as the basic right of all individuals and couples to decide freely and responsibly on the number, spacing, and timing of their children, to have the information and the means to do so, and to attain the highest standard of sexual and reproductive health.
Okay.
Crucially, this includes making decisions free of discrimination, coercion, and violence. So it fundamentally links these rights to recognize human rights like the right to health, freedom from discrimination, and privacy.
But these rights aren't universally accepted, are they? I mean, our sources point to significant political and cultural opposition, which complicates efforts to establish global standards.
That's a really crucial point. While international documents like the Cairo Program of Action or the Beijing Platform have framed women's reproductive rights as indivisible, universal, and inalienable, many states, particularly in Latin America and the Islamic world, have made formal reservations.
Reservations meaning they don't fully agree.
Exactly, citing incompatibility with religious law or specific issues concerning abortion. Even the U.S., under certain administrations, has opposed efforts to strengthen these rights in international forums. This intense politicization makes enacting consistent legislation globally incredibly challenging. It leads to highly variable access and protections worldwide.
So beyond the specific technologies and legal frameworks, our sources paint a pretty stark picture, revealing how violations of fundamental human rights often intersect with reproductive freedoms globally. What are some of the most pervasive issues that come up?
Well, we see horrifying examples of violations of bodily autonomy, things like compulsory sterilization, historically used against ethnic minority women in places like Peru and also in eugenics programs in the US and Canada back in the day.
Right.
Similarly, non-consensual surgical interventions on intersex individuals, often performed on infants to normalize their sex characteristics. These have been condemned by the UN and WHO as serious human rights violations. They often lead to permanent infertility and severe mental suffering later in life.
That's awful.
Then there's the pervasive impact of gender-based violence. Everything from forced marriage and child marriage to sexual violence in armed conflict. These fundamentally deny individuals control over their bodies and their reproductive future. And for millions, just the basic access to safe health care and information is denied. The WHO states safe legal abortion is a fundamental right, yet an estimated 25 million unsafe abortions occur annually, mostly in developing countries,
25 million.
leading to significant and preventable maternal mortality. And even birth control itself still faces strong opposition in many places. Lack of knowledge about existing laws is another huge barrier.
And it's important to remember it's not just about women's rights here. These conversations about bodily autonomy and reproductive freedom need to be inclusive of everyone.
Indeed. Men's reproductive rights, for instance, encompass issues like STIs, certain cancers, exposure to toxins that impact their reproductive health. The concept of a male abortion has also been raised, though it's highly controversial. It concerns a putative father's right to somehow terminate his legal interests and obligations to an unborn child before birth. But all these discussions really highlight the critical importance of bodily integrity and informed consent for all individuals, regardless of their gender identity or biological sex.
Wow. Okay. This deep dive has truly laid bare the incredible advancements, yes, but also the profound ethical, legal, and social complexities surrounding reproduction and genetics. From three-parent babies to the fight for genetic privacy against, foreign adversaries, and the fundamental struggle for basic reproductive rights. It's clear these aren't easy questions for anyone to navigate.
What's really fascinating here, I think, is that constant tension. The tension between breathtaking scientific progress, the fundamental right to individual autonomy, and our diverse, often conflicting societal values. Our sources consistently highlight the need for much greater public dialogue, for robust regulatory frameworks that aren't overly influenced by commercial interests, and for improved data transparency, especially concerning things like donor registries, to ensure the well-being and rights of all individuals involved, and frankly, future generations too.
So what does this all mean for you, the learner? It means staying informed, Definitely. Asking critical questions and recognizing that these conversations about life, ethics, and human rights are really far from settled. The decisions we make collectively and individually, and the policies we support, will literally shape our shared future. We really encourage you to continue exploring these topics because understanding them is truly a shortcut to being well-informed in this rapidly evolving world. Perhaps the most provocative thought to leave you with is this. How much control should we actually seek over the blueprint of life? And what does that pursuit ultimately reveal about our own humanity?